So topic 2 is titled Understanding Factorization. So we first need to look at a few definitions. So first of all, factors are numbers that are being multiplied. So if I think of 2 times 3, 2 and 3 are factors. In fact, they're factors of 6. So further, a factor is any number that divides another number evenly, meaning there's a remainder of 0. So let's go back to this idea of 2 times 3. So we have 2 times 3 equals 6. We're saying 2 and 3 are factors because they're being multiplied. But further, if I take 6 and I divide it by 3, it divides in evenly. 6 divided by 3 is 2. If I take 6 and I divide it by 2, I get 3. So 2 and 3 divide into 6 evenly, meaning there's no remainder. Okay, so that makes them factors of 6. A factorization is a way to express a number as a product of factors. So 2 times 3 is a factorization of 6. Now, a prime number, that's our next definition. A prime number is any natural number. That means a number that's one or more incrementing by one. So no decimals, no fractions, no zero, no negatives. Okay, so a prime number is a natural number that has exactly two factors, one and itself. So there's no way to write a factorization of a prime number other than just taking that number and multiplying it by one. So like 3 is a prime number. There are no two numbers, no two natural numbers that would multiply to give us 3 other than just 1 and 3. 11 is a prime number. There's no other way to write 11 as a factorization other than just 11 times 1. Now, on the flip side of that, we have composite numbers. So a composite number is any number other than 1 that is not prime. So for example, 6 is considered a composite number because there's more than one way to multiply numbers and get 6. I could take 1 times 6, that's a factorization of 6, but I could also take 2 times 3 to get a factorization of 6. So in the world around, we use both of these numbers a ton. You'll see lots and lots of composite numbers. Now, back to this idea of factorizations. A prime factorization is a way to express a number as a product of only prime factors. So for example, if we go back to this idea of 6, we have a factorization of 6 that is 2 times 3. Both 2 and 3 are prime, so 2 times 3 is a prime factorization of 6. And prime factorizations are really useful when you start talking about simplifying fractions. So one way that we can simplify fractions is to look at prime factorizations. But first, let's practice just factorizations. So example 3 in this worksheet, we have directions that say list 3 factorizations of each number. So we're going to take each of these two numbers that they've given us, and we're going to find 3 different ways that we could write it as a factorization. Now remember, that's writing it as a product. So for 24, I could take 1 times 24. That's certainly a factorization. 24 is also divisible by 2. So 2 into 24 goes 12 times. 24 is also divisible by 3. So I could take 3. It goes into 24 8 times. So that's our 3 factorizations. There are a couple of more. We could also have 4 times 6. Okay. Or if we wanted to, we could go even further and we could say 2 times 2 times 2 times 3. Now, believe it or not, if I multiply 2 times 2 times 2 times 3, I will get 24. So that's that special kind of factorization. This is the prime factorization of 24. Okay, so just know that when you have a prime factorization, it'll oftentimes be more than just 2 factors. Okay, now let's look at 60. I could certainly write 60 as 1 times 60, so that's a factorization of 60. 60 is divisible by 2. 2 goes into 60 30 times. 60 is also divisible by 3. 3 goes into 60 20 times. So that's 3 factorizations, but if we wanted to, we could keep going. So we could also take 4 goes into 60. So we could take 4 times 15. 5 goes into 60. 5 goes into 60 12 times. 6 goes into 60 10 times. And then I think that's all of the just two. Let me fix that one. Hold on. I think that's all of the two number factorizations of 60. We could get a prime factorization, but we'll learn prime factorizations in this next example. Okay, so a factorization is just any way to rewrite a number as a product of factors. Okay, so looking at example 4, it says determine the prime factorization for each number. Express in exponential notation. So if we go back up here to 24, we found several factorizations. This special one right here, the 2 times 2 times 2 times 3, that was very specifically the prime factorization. So let's learn how to calculate prime factorizations. So in math, we have these things called factor trees. So at the top of the tree, you have a number, and your goal is to break it down into branches that represent factors of that number. So let's start with 56. So you can think of kind of a stereotypical Christmas tree. The 56 is sort of the tree topper, and then we're going to bring down branches. Each branch is going to have a factor that would kind of represent an ornament. Now, you can come up with any two factors of 56 except for 1 and 56. So I happen to know that 8 times 7 is equal to 56. Well, 7 is a prime number, so I just want to bring 7 down another layer. 8 is not a prime number. 8 can be broken down as 2 times 4. So at this point, if I took 2 times 4 times 7, I would still get 56. The issue is 4 is not prime. So I would need to bring down my prime factors. So 2 and 7 are already prime. All right. But 4 is not. So I need to write 4 as the product of two factors. So 4 can be written as 2 times 2. So now I have 2 times 2 times 2 times 7, and that's the prime factorization. All of those factors along the bottom line are prime numbers. The directions did say to express in exponential notation. So I have 2 multiplied by itself 3 times, so that's 2 to the third times 7. And that's the prime factorization of 56. Let's go ahead and look at 360. So we're going to start the same way. We're going to come over here and we're going to look at 360. You want to come up with any two factors of 360, any two numbers that multiply to be 360 except for 1 and 360. Now, I happen to know that if a number ends in 0, it's divisible by 10, and that's going to be a nice place for us to start. So we could take 10 times 36. Well, 10 is not prime. 36 is not prime. So 10 can be written as 2 times 5. 36 can be written as 6 times 6. Now for 36, you could have done 4 times 9. You could have done 3 times 12. You could have done 2 times 18. I just happened to choose 6 times 6. So again, you can choose any two factors of these non-prime numbers, okay? Now, 2 is already prime. 5 is already prime. 6 is not. So we need to come up with two numbers that multiply to give us 6. That would be 2 and 3. And we're going to do that for both of the 6s. Now, this is kind of a mess, but if you look, we have 2s, 3s, and a 5. They're all prime numbers, so let's just write them in order from smallest to largest. So I get 2 times 2 times 2 times 3 times 3 times 5. Make sure you get all of your factors. So I've got my 2s, I've got my 3s, I've got my 5. And now what we want to do is we want to write this in exponential notation. So 2 got multiplied by itself 3 times, so that's 2 to the third. 5 got multiplied by itself twice, so that's going to be 3 squared. And then there's just that 5 that's all by itself. So the prime factorization of 360 is 2 to the third times 3 to the second times 5. And if you take 2 times 2 times 2 times 3 times 3 times 5, you will get 360 when you multiply. So again, just in short, factorizations are just ways of rewriting a number as a product. You have just any old factorization, and then you have very specifically a prime factorization, which is made up of all prime factors, where prime numbers are numbers that can only be written in one factorization, and that is 1 times the number itself. Composite numbers, on the other hand, have more than one way to rewrite them. So they have more than those two factors. All right, so make sure you practice factorizations.